Shawn, could you tell us about high-level synthesis?
High-level synthesis moves design automation up to the next level of abstraction. So in other words, it changes the synthesis input from RTL to C or to some C variant. The output of high-level synthesis is RTL, which then is used to continue through the rest of the established RTL methodologies. There are a few key trends that are driving the adoption of high-level synthesis. Probably the biggest one is verification. I see every single customer that I go to is focused on how do I reduce my verification time. The second one is design complexity. Complexity of designs have increased tremendously over the last several years. And the final one, and I think we can all relate to this, is the economic pressure. We have fewer resources and we're supposed to try to do more with those resources. I'm seeing high-level synthesis gain traction worldwide from its initial deployment in Japan and Europe to now the United States. In fact, if you look at some of the more public user forums, you can see a number of engineers that have written into these forums that are saying quite significant things. One engineer commented in John Cooley's Deep Chip that he was able to reduce his design time by 40%. In other words, he took his design from 10 weeks down to 6 weeks, and he was able to get verified RTL at the end of the process. The second engineer wrote that he was able to take his design down from 6 months to 2.5 months, representing a 60% reduction in design time. All of the user pieces that I've been seeing submitted into John Cooley's Deep Chip as well as other forums, to me is very, very exciting to see such traction and such adoption of high-level synthesis as well as the end result that they're able to achieve.